Good afternoon, everyone. It is afternoon, and I'm really pleased to welcome our Indian colleagues and friends over from Mumbai who are working for RELSAFE CRA Consulting. A good friend of mine, Devi Kompella, runs that organization. So today we have Karthik Ravichandran and Rahul Agarwal, who are specialist PRA consultants. And what they will be doing is giving us a good understanding of a potential energy scenario where the environmental policies and the nuclear power plant licensing process, how it works within India. And clearly India has lots of CO2 emissions which need to be managed, and the electricity system needs to be decarbonized. A lot of coal is still being burnt over there. So we're interested to see how that challenge is being tackled. I'll pass you over to Karthik and Rahul. Thank you very much.
Thank you very much. Yes. Good afternoon, everyone. Firstly, on behalf of RELSAFE, I want to thank CRA for giving us this opportunity to share our thoughts in this forum. So in this session, my name is Karthik Ravichandran. I have my colleague Rahul Agarwal here with me. So we will talk about the energy scenario, the environmental policies, and the licensing process for the nuclear power plants in India. So the presentation will we will start with a brief introduction about the company and the speakers, and then we'll move on to the current energy scenario and policies in India. Then some information on the three-stage nuclear power program and details of the existing nuclear power plants and what is the proposed growth plan for the nuclear energy sector, and what is the need for the environmental impact assessment process, and finally a quick overview about the licensing process for NPPs. Yeah, so what the a company, RELSAFE, provides technical consulting services in the areas of safety, risk, and reliability. Our core expertise is in performing probabilistic and deterministic safety assessments. Majority of our business is with the nuclear power sector, but we do provide safety assessment services also for the oil and gas and other process industries. We have been delivering long-term PSA and DSA projects and training program to power plants, regulators, and EPCs, mainly in some of the European, Asian, and Latin American countries. And more recently, we have been involved in providing some advisory support to EDF for the proposed EPR project in India. We'll be talking about that later. So during this process, we are interacting with some of the senior experts from the Indian nuclear industry, and we have also started to learn about the licensing regime. So this presentation also gives some highlights of this process with relevance to the environmental policies. Yeah. About us, I'm a principal consultant, a mechanical and nuclear engineer with 10 years of experience in performing probabilistic and deterministic safety assessments, supporting the Swiss, Belgian, and French power sectors. I'm also responsible for the technical coordination of projects related to hazards, internal and external, and I also manage the company operations. My colleague Rahul Agarwal, he's a senior consultant. He's an electrical and construction management and technology engineer with over 8 years of experience in probabilistic safety assessment, working for the Swiss and Belgian power sector. So he's also a senior technical coordinator for projects and supporting me in the management of company operations. So now I'll ask my colleague Rahul to initiate this presentation and talk about the first few topics.
Thank you very much, Karthik, for the introduction. Over the next few slides, I am going to take you through the current energy scenario, the energy policies in India, and also the nuclear power program in India, how the growth plan is aligned towards the target, the net zero target that India is set to achieve. So I will take you through that. Starting with the current energy scenario in India, India's power sector is one of the most diversified in the world. The sources of power generation range from conventional sources of energy like coal, lignite, natural gas, oil, hydropower, and nuclear energy. It also has non-conventional viable sources such as the solar, wind, agriculture, and even the domestic waste through which India generates electricity. Now, looking at the sector composition, the renewable energy sources, the hydro power, the nuclear power, they contribute to about 40% of the total installed capacity of India. Surely 60% of the stake is still with thermal power plants which are fired by coal and oil and natural gas. But I would still say that India has a lot of initiatives aligned to increase the energy efficiency of the thermal power plants, existing thermal power plants, by employing the supercritical technologies. And it also has plans to grow the renewable energy sources installed generation capacity over the years. By 2030, mostly it would be doubled. And also the nuclear power will grow from 6.8 gigawatts to 23 gigawatts by 2030. So India already has plans, and it has it will meet its net zero target as well in the coming decades. Now, looking at the key trends, India is a developing nation, so what we see from the trends is that over the last 5 to 6 years, India has grown its installed electricity generation capacity by about 100 gigawatts. The growing population and being the developing nation, the electricity demand is generally to rise, and it is further expected to rise in the coming years. The electricity demand again can be only met by massive addition of the capacity generation to the Indian grid. Now, when we look at the per capita electricity consumption, it is currently low as compared to the developed countries like the UK, US, France, and Canada, and so on. But then India is still the third largest producer and the second largest consumer of electricity in the world, with an installed capacity of 384 gigawatt as of May 2021. Now, talking about the Indian energy policies, India is also third largest emitter of greenhouse gases after China and the US. But then India also has a threat. India is also vulnerable to climate change. For example, the melting of the Himalayan glaciers or the ice peaks, or even the change to the monsoons. So India has also pledged, India has signed the Paris Climate Agreement in 2016 towards a clean energy policy, and India has committed to cut greenhouse gases intensity by 33 to 35% by 2030. To increase the non-fossil fuel power generation capacity to 40%, and also to increase the substantially increase the tree cover, which would accommodate for the carbon emissions, adding to the carbon sink, existing carbon sink of India. And it would probably have the capacity to take about the emissions over 1 year. India has also signed the treaty towards the second commitment period of the Kyoto Protocol, and its policies are also aligned towards the set of 16 Sustainable Development Goals, and that is one of our government's initiative. Nuclear power will definitely play a role in achieving the Sustainable Development Goals, being Goal 7 being the securing the affordable and clean energy for the population, and also the climate action where green technologies are going to play a role. Talking about the present scenario, India is in a good track to achieve the Paris targets. As we saw, the renewable energy and the hydro power and the nuclear power, they cumulatively contribute to about 40%. So the target is being achieved even a decade earlier than the set time frame of 2030. It is also projected that India will cut down the greenhouse gas emissions to about 50% of what it was observed in 2005. So it will definitely overachieve the Paris targets by 2030. Now, when we talk about India's commitments towards the net zero target, of course, investments are going to play a big role. The implementation of India's commitments will heavily depend on the climate finance, technology transfer. There is also capacity building support from the developing nations. So India has to make significant investments over the next few years. I would say there is a projected estimate of about 2.5 trillion US dollars that has to be that is required to meet the targets from the domestic and even the international funds that are there to achieve the targets. So if we look at the growing demand, India has already allotted about 90 billion US dollars in between 2010 and 2019 towards clean energy, which puts India as a sixth nation to make such a significant significant investment in clean energy. Uh, Energy sector is also a prime focus for India. So there are higher investments. It has a highest share of about 24% of the total expected capital expenditure, which is about 1.4 trillion US dollars. There is huge policy support in India. There are initiatives, there are schemes by the government, propelled by the government towards the increasing electrification across the country. One such example is Integrated Power Development Scheme. Now, this scheme was launched with the sole objective of strengthening the transmission and the distribution sectors in the urban areas. It is also going to reduce the AT&C losses, basically the technical and the commercial losses during the transmission, and also involved in the billing, the energy accounting, and the auditing process of India. India has also allotted in their union budget 2021 and 2022 about 42 billion US dollars for reforms based and result linked new schemes in the power distribution sector. So these are some of the financials that I wanted to show you and how India is going to achieve its net zero target. Now, benefit of nuclear energy. India's perspective is not very different from the other developed nations, though India, being a large nation, it wants to rely on indigenous raw materials for its long-term sustainability. So nuclear plays a very vital role in this area because India has large reserves of thorium and uranium. And and nuclear power, of course, it provides a carbon-free future. So for India, nuclear power is vital to meet the growing demand of electricity, to also address the concerns about the climate change, reduce the carbon emission footprint, and also replace the electricity generated by the thermal plants in future. Also redress the volatile fossil fuel prices from coal, and changing prices of oil and natural gas, and finally ensure the security of energy supply by meeting the base load electricity generation, which of course we know that it cannot be provided by solar or wind. There is also an ambitious three-stage nuclear power program, which has an ultimate objective of utilizing the vast reserves of thorium, and thorium being a clean and safer alternative to conventional nuclear fuels, as we all know. So talking about the three-stage Indian nuclear power program, the main aim is, of course, to secure the long-term India's energy independence by utilizing the vast reserves of thorium and uranium. And what is three-stage all about? Let us look at the three stages. In the stage one, the pressurized heavy water reactors are fueled by natural uranium-238, and not the so there is no enrichment of uranium required at this stage, and it is used to generate electricity and also produce plutonium-239 in this stage. So this stage it was very beneficial for India because it was easier to build heavy water manufacturing plants rather than uranium enrichment facilities, and it has been going good for the last so many decades that India has been operating PHWRs. Coming to the next stage, which is fueled by a mix of plutonium and natural uranium. Plutonium is basically undergoes fission and it generates electricity, whereas uranium-238 transmutes into plutonium, and thus this stage 2 reactor, it is being branded as to breed fuel more than it consumes fuel. So that is one of the advantages of stage 2. And thorium also is introduced as a blanket material in this stage 2 reactor, which will again transmute into uranium 233, which will be a fuel to the next stage reactor, which is stage 3. So in stage 3, again, stage 3 is a very advanced nuclear power system reactor, which is a self-sustaining series of thorium and uranium 233 reactors. It is basically a thermal breeder reactor, and it is self-sustaining because after the initial fuel charge, it can be refueled by just using the naturally occurring thorium, which is, of course, plenty of reserves are there in India. So looking at the status of the 3 stages of nuclear power program, as I said, PHWRs are already operational in India for last 3 to 4 decades or even more, and we are going towards stage 2, the fast breeder reactor, which will achieve criticality in 1 or 2 years time, probably, because we are very close to achieving criticality. And stage 3, it might take some time, but we still have the experimental Kamini reactor, the thorium based reactor, 30 kilowatt, which is operational. And yeah, that is where we are with the 3-stage nuclear power program. And this program, it really helps India to build largely indigenous nuclear power plants in India. India has been outside the non-proliferation treaty, but it has civil nuclear agreements with a lot of developed nations, several developed nations, for example, US, UK, France, Japan, and many more. So these nuclear deals definitely are going to help India to grow their nuclear energy in the coming years. As of August 2021, India has about 22 operational nuclear power plants which are connected to the grid, and their capacity is about 6.8 gigawatts, which I told you earlier. And then the installed reactor types, basically the majority of the reactors are pressurized heavy water reactors, indigenously designed and constructed in India by the Nuclear Power Corporation of India Limited. We also have BWRs, boiling water reactors. We have Russian VVER, pressurized water reactors, and we also have a prototype fast breeder reactors at Kalpakam site. So these are the existing nuclear power plants in India. Then talking about the proposed nuclear growth plan in India. By 2030, India plans to increase the installed capacity by 15.7 gigawatt. So that makes up to 23 gigawatt by 2030. And there will be 21 new nuclear reactors coming up. 9 nuclear reactors are already in the various stages of construction and targeted to be online by 2024 or 2025. And other 12 nuclear reactors, they have been all accorded administrative approval. Most of them are PHWRs. In addition to the 21 nuclear reactors, we have 5 nuclear reactor sites that again have been accorded approval by the government. And these are going to be constructed in cooperation with various other nations. For example, we have the 6 EPRs being planned at the Jaitapur site in cooperation with France, EDF. We have the light water reactors in cooperation with USA. They are going to be planned at the Kovada and the Chayamiti Virdi site. And there is also six reactors of 1,000 megawatt each in cooperation with Russian Federation at the Haripur site. And then there is also the indigenous PHWR by India itself, which is 4 reactors of 700 megawatt in the Bhimpur site. So it will contribute to about 32 gigawatts of total capacity. Now, talking about one of the highlights and one of the very ambitious projects of India, which is the Jaitapur project, Jaitapur Nuclear Power Plant project. It has 6 EPRs, each of 1650 megawatt, and it is being propelled in cooperation with the EDF, France. EDF has already submitted a binding techno-commercial offer to Nuclear Power Corporation of India, and it's all over the news, and we all know about it. So further, environmental clearance has also been obtained for Jaitapur nuclear power plant by the Ministry of Environment, Forest and Climate Change in the year 2010, and also after the public hearing and organized by several pollution control boards and also a deep review of the environmental impact assessment report submitted by the NPCIL. So this is going to be a very beautiful project. I mean, this is going to be world's most powerful plant, and it would provide electricity to 70 million households and also avoid 80 million tons of CO2 per year, which is amazing. And it will also create hundreds and thousands of local jobs for the people here. So this was an overview of the nuclear power program at India, and also the energy policies at India, how we are going to target the net zero. Now I will hand over to Karthik. He will go forward with the environmental impact assessment aspects and also the nuclear power plant licensing process in India.
Yeah, thank you, Rahul. Right. So to continue with the environment impact assessment, so why do we need such an assessment for nuclear facilities? Because there is no such thing as zero or close to zero emission nuclear power plant. We all know that during when an NPP is operating, the direct carbon dioxide emissions are quite low. But considering the whole life cycle of the plant, right from the uranium mining, fuel fabrication, construction, until the decommissioning and spent fuel processing, the indirect emissions may contribute considerably. So it's important to regulate and control the greenhouse gas emissions throughout the life cycle of the plant. And another aspect is that until the construction phase, a nuclear power plant is similar to any other industrial installation, because all these they present similar pollution concerns. But when a nuclear power plant starts operating, then the radioactivity release concern also arises, which needs to be regulated. So to address these aspects, the Ministry of Environment and Forest, and along with the regulator, the Atomic Energy Regulatory Board, they introduced the environmental impact assessment process, and now this has become a part of the decision making when it comes to development of nuclear facilities. So, in the first step in a typical licensing process is the siting consent. So, for when the utilities want to get the siting consent, the first thing that is required is the environmental clearance. It's a precondition. So, the utility is required to submit an environment impact assessment report, EIA report, which will be reviewed by the expert appraisal committee that's constituted by the ministry. And after this, there is a public consultation phase, which is an essential prerequisite now for the clearance. And so this the process is that the process requires that they understand the concerns of the local population and other stakeholders for facilitating the clearance process. So after this, the committee again does a detailed review of the application along with the final EIA report and the outcome of the public consultations in order to grant the environmental clearance. So this EIA report contains baseline data for different types of environments. So a few examples are given here. So if we take the land environment, data on the topography, geology, and the soil quality data are required. When it comes to air environment, mainly the data on the gaseous pollutants like the dust and gases are going to be released during different activities like construction and road traffic and a few other activities. Data on conventional pollutants and background radiation levels, meteorological data, wind, rainfall, humidity, temperature, and so on. Similarly, for the water environment, data on the groundwater quality, location of surface water, the marine and the oceanographic data are required. For the noise environment, data on the noise levels in the project area and the neighborhood. For the biological environment, data about the distribution pattern, community structure, and the species composition of flora and fauna, and also the background radiation levels that they are exposed to. And finally, the socioeconomic and the occupational health and safety environment, which includes data about influences on the local community. So there will be village relocations, industrialization, population growth, about the employment, livelihood, and so on. And in addition to all these environmental aspects, one more additional point that I would like to mention is that all nuclear power plants in India have a feature that minimizes the radiation exposure to the public and environment. So that's called as the zoning. So all plants have 4 levels of zones. floor levels of zones surrounding the site. So the first is the exclusion zone, that is covering 1.5 kilometers from the plant site, where this is under the total control of the plant and no public is allowed without permission. Then there's a sterilization zone that covers 5 kilometers from the plant site, where no new activity is permitted and only the existing activities are controlled. Then there's an emergency planning zone that covers 16 kilometers, and then finally an impact assessment zone that covers 30 kilometers. So I talked about the environment impact assessment. So till date, these are the nuclear power plant sites in India where for which the environment impact assessments have been completed and the clearances obtained. And there are a few new projects where these studies are at the advanced stages. Next slide. Yes. Now coming to the licensing process, in India, the licensing process is also referred to as the consenting process. And as we all know, this is a very extensive area. So we have focused our slides more on the requirements on the environmental studies that have to be submitted during different stages. Next one, please. Yes. So there are two main organizations involved in the licensing process. So one is the regulatory authority, the other one is the plant operator. In India, the Atomic Energy Regulatory Board is the regulatory authority. They issue three types of documents. One is the safety codes and standards, which establish the objectives and mandatory requirements that have to be fulfilled by the utility to provide the assurance for safety. The second one is the safety guidelines, which recommend approaches for implementation in order to meet these requirements. And the third one is the safety manuals that contain detailed technical information about different topics. The other one is the plant operators. So Nuclear Power Corporation of India Limited is the responsible for construction and operation of all the commercial nuclear power plants in India. Next one. So these are the different stages in the consenting process. So we have 5 stages starting from the siting. Then we have the construction, commissioning, operation, and decommissioning. As I mentioned before, public consultation is an important step in this overall process, which is given a good weightage. Next one, please. Right. So these are some of the main submissions required for each licensing stage. In the interest of time, I'm not going into the details of every submission, but I would like to just highlight some of the submissions related to the environmental studies. So, for example, in the siting process, we have the site evaluation report, and with all the details that I shared with you a few slides back. So this site evaluation report is part of the environmental impact assessment. And apart from that, there is also a report on the dose apportionment, considering the different effluent release pathways to environment. And there is also a requirement to submit a radioactive waste management plan in the siting process. Then comes the construction stage, where there is a requirement to update the radioactive waste management plan and issue also a radiation protection document. In the commissioning stage, there needs to be a compliance proved to a couple of AERB safety guides, which are the radiation protection for nuclear fuel cycle facilities and management of radioactive waste. Next one, please. Yeah. Coming to the operation stage, so they have 2 stages. First is the initial operation. So based on the review of the final safety analysis report, the regulator grants the license for initial operation for a period of 5 years. And in the next stage, once the initial periodic safety review is done, based on the review of this process, the regulator is going to grant further license for operation for another 5 years, so in total 10 years. And one of the submissions required during this phase is the updated radiation protection manual and the fire hazard analysis report. In the last decommissioning stage, there are a few reports to be submitted. So in addition to the main decommissioning plan, there is a requirement to submit radioactive waste management plan, the spent fuel management plan, and also the final environmental impact assessment for the proposed activities during decommissioning. Yeah, next one, please. So, concluding remark. So if we consider any type of energy source, there is always a trilemma between the carbon emissions, the supply, and the cost. Nuclear energy addresses the first two aspects, that is the carbon emissions and the continuity of supply. And now with the advancement in reactor technologies, it is also becoming quite cost competitive. So India is now actively moving ahead with the ambitious nuclear power program, and it considers this energy source as the most favorable alternative, viable, and for the baseload electricity generation, and also to curb the emission levels to achieve the net zero target. So yeah, so that's the end of my presentation. Thank you for your time.
Thank you very much, Karthik and Rahul. That's really good, concise and succinctly put the position in terms of how India is meeting its CO2 and net zero challenges and targets. Really apologise for the gremlins earlier and stopping you in full flow at that particular point. I know we're over time. We've got lunch organised on this end. Just got two quick questions. One is the 15.7 gigawatt projection by 2031. What percentage of the nation's energy will be nuclear by that time compared to renewables and other sources? Do you have a figure for that? Oh, sorry, Rahul, I think you're on mute.
Yes, so I was saying that by 2030, if we achieve the target of having 23 gigawatts or 32 gigawatts by 2030, then we would be around 3 to 5% of the total installed capacity of India.
Sorry, did you say 4 to 5%?
4 to 5%, yes.
Okay, so that's still quite low, isn't it? Because of the sheer amount of energy that you're predicting the use.
Yes, it is. For now, it is just over 2%. And then by 2030, we are also going to increase the renewable energy sources generation. So the ratio is going to go up even for the renewable energies. And for the thermal plants, it would still stay in operation because we are not thinking to phase them out until 2050. India is a developing nation and we have a growing demand. So.
Oh, that's fascinating. And so will you be looking into carbon capture technology then for the thermal plants?
Yes, there are initiatives from government. We also have employed supercritical technologies for thermal power plants. But yeah, in the long run, thermal power plants are going to be phased out by 2050, and the phase out, nuclear energy is going to be the one to phase out the coal plants.
And finally, before we finish, can you just briefly tell us how the heavy water pressurized water reactor design has evolved over the years?
So for the development and the evolution of the heavy water reactors, there are also key drivers like improving the economy of the operation, and there's also evolution in the safety process, and also there is moving toward the sustainable development. Now also improving to improve the energy, the nuclear energy in the India's energy mix. The heavy water reactors, we started with 220 megawatts and then we moved up to 540 megawatts, and also we now have 700 megawatts PHWRs. Then there was also moderate development for the reactor shutdown to employment of redundant shutdown systems. So with the liquid poison injection systems. So yeah, I mean, also there are developments in the design as well, where the different like the pressure tube heavy water cooled reactors, pressure vessel heavy water cooled, and pressure tube light water cooled, and there are several design developments that has happened over the years. So yes.
Very good, and thank you very much for that. I mean, it's fascinating to see a nation like India taking control over its critical national infrastructure, investing all those billions and trillions into making sure it remains within the nation's control rather than outsourcing it all. Wonder where that happens a lot. Anyway, thank you very, very much for your time.